Okay, this is Professor David Julius Reyes. Okay, my topic for this session will be a long video format discussion on college algebra, and this will now be the so-called heart and soul of college algebra. Uh, all our may retiring thing on the so-called fundamental operations and the proper way on how to compute an equation, we will now apply to the so-called solution of a linear equation. Okay, let's proceed. My topic for tonight will be college algebra, lesson number 71. Lesson number 71, the title of the topic is linear equations, meaning to say the solution of a linear equation. In real life, there are so many problems which could be represented in terms of a linear equation. And to solve that one, we will be applying the solution we will be studying tonight. Okay, let's try to define what is a linear equation. Linear equation is actually, the other term is a so-called first degree equation. First degree, meaning if the unknown is x, right, the power of x is just x to the 1, or just simply x. 1 refers to linear, or the other term is actually first degree. Okay? So if we try to bring out the form of a linear equation under the study of college algebra, it will be of the form ax plus b equal to c, where the value a, b, c are all real numbers, and there's a condition for this to be linear. A should not be equal to 0, because if a is 0, a 0 times x will be 0. Okay, so we don't have anything. Okay, so for the equation to be linear, okay, a, b, c should all be real numbers, and the other condition is that a should not be equal to 0. The equation is just linear. It's an easy thing, right? Because the highest power of x is just x to the first, or just simply x. Okay, it's not very tiresome, Okay, let's try to bring out how to solve a linear equation. With all the knowledge that we had passed by under the study of college algebra, from the fundamental operations to the simplifications and other things, right? We will now apply those knowledge in here. So whatever knowledge we have discussed, okay, starting from lesson number 1 going up till here, right? We will apply it here. Okay. How to solve a linear equation? To solve a linear equation, meaning we must have to compute for x. Solve an equation in x. If the unknown is represented by x, but it could be represented by another variable. It depends on the problem. If the problem give us a linear equation in which the variable is y, you should solve for y. Because if it is in terms of y and for you to solve it for x, that's another thing, right? So if the linear equation is in terms of y, we must have to solve for y, right? If it is in terms of letters a, you should compute for letters a. X, y, z under the study of algebra are all variables. Okay, and number 2, the proper way and how to solve it, try to isolate x on the left hand side. This portion here, this x here. Try to maintain the location of x to be always on the left hand side, and all constant terms to the right. That's why under how to solve, isolate x on the left. If you isolate x on the left, meaning all the constant terms should go to the right. Okay, that's the proper way to solve the equation. Whatever operation is needed, just perform it. Okay, let's try to bring out an example problem. Example number 1, solve the linear equation. The given linear equation is 5 times the quantity 2p minus 5 close quantity plus 2 times open quantity p minus 3 close quantity, and this should be equal to 4 times the quantity p minus 1 close quantity. The variable here is not x, it is p, so obviously we are solving for p, right? Like what I said, if the given variable is p, you must have to solve for p. If the given variable is in terms of x, you must have to solve for x. Okay? The procedure is the same. Whether you are solving for x or p, the procedure is the same. Okay, let's try to bring out the solution. Oh, by inspection, what will be the first step? Of course, we must have to distribute, right? Distribute. So we will be using the so-called distributive law, right? If 5 times 2p will be 10p, 5 times minus 5 will be minus 25. This is plus, so there's no danger, right? 2 times p will be 2p, 2 times minus 3 will be minus 6. A plus and a minus will be minus. Fundamental operations, right? Like what I said, whatever concepts we have studied under fundamental operations, we will all apply it all here. Right hand side, 4 times p will be 4p, 4 times minus 1 will be minus 4. A plus and a minus will be minus. Or what will be the next step? Okay, combine similar terms. Don't do anything yet for both the left and right, just combine the similar terms for both the left and right. So we'll combine the similar terms on the left hand side. All terms with the p. All terms with the p. This is 10p, right? This is 2p. We add it. 10p plus 2p. We are adding two positive numbers, so it will be plus 12p. And minus 25 minus 6. If you add two negative numbers, it will be the sum of their magnitudes. You put a negative sign, negative 31. Okay, and this should be equal to 4p minus 1. Okay, let's try to clear first the left hand side of any constant. So I will rewrite 12p. I will rewrite minus 31. I would like this minus 31 to be eliminated, so I will add plus 31 here, right? So I will add also plus 31 on the right hand side. Whatever you do on the left, do it on the right. Okay, to eliminate this negative 31. We added 31 here, so we added 31 also on the right hand side. So this one cancels. What remains on the left will be 12p equal to 4p. Minus 4 plus 31 is positive 27. Or what will be the next logical step? On this, how to solve isolate x on the left, right? There's a 4p here. P is still the unknown. So we must have to eliminate this one on the right. Okay? We eliminate it on the right, we put it on the left. So what we'll do? We will rewrite 12p. I will write negative 4p here. I will rewrite 4p on the right hand side. I want to eliminate this one, so I must have to subtract a value same as its value, minus 4p. So this is minus 4p, okay? We subtract minus 4p, we subtract minus 4p, okay? Plus 27. After subtracting minus 4p on the right hand side, this cancels. Because actually the object of the subtraction is actually to eliminate that 4p on the right hand side. So on the left hand side, these are similar terms, right? A 12p minus 4p will be 8p. And for the right hand side, since this cancels out, what remains is just 27. Okay? We will try to compute for p without a, right? So we will divide the left hand side by 8. We divide the right hand side by 8. If we try to divide the left hand side by 8, this 8 here cancel with this. This is 1, this 1. So P now will be equal to 27 over 8. That will be our answer. As simple as that one. So if you try to notice it, for every step, we are actually using the concepts in the past lessons, right? Whatever concept that will be needed, apply it. Okay, example number 2. Solve the linear equation. The given linear equation is negative 25. Am I still on camera? Negative 25 times the quantity x minus 100 equal to 16 times the quantity x minus 100. Try to solve for x. Luckily for the second example, the variable is x. Right? Okay. What will be the first step, you think, guys? Of course, we distribute. Negative 25 times x will be negative 25x. Negative 25 times negative 100. And negative will be positive. That will be 2500. 16 times x will be 16x. 16 times negative 1. A positive and a negative, this will be negative. So this should be negative 1600. Okay. What will be the next step? We don't touch the right hand side yet. We will clear out first the left hand side of any constant. Okay. There is a constant on the right hand side, right? 2500. So for this to be free of any constant, we must have to eliminate this one, right? So what do? We rewrite this one. We subtract negative 2500. If we subtract it also on the right. So we don't change the value of the equation, right? Negative 2500, negative 2500. This one, rewrite this 16x minus 1600. So after the subtraction of negative 2500, actually this cancels, right? So what remains on the left? The left hand side is now free of a constant that is added to it. So negative 25x equal to, we simplify the right hand side, 16x. This is a pure constant. The pure constant is negative, so we take this out, but the overall side should be negative. It is negative 4100. Okay. There is still an x on the right? So we must have to bring this one to the left. Okay. So what do? Negative 25x. We subtract negative 16x here. This one, for it to go to the left, okay, we rewrite it, but we must have to subtract negative 16x, right? So because this is actually negative 16x, we subtract negative 16x, we subtract negative 16x. After the subtraction, actually, we eliminated this 16x on the right. Okay. This 16x here cancel with this, right? So after the subtraction of negative 16x, these two here are similar. They are both negative. So the overall sign will be negative. The magnitude will be the sum of the magnitudes negative 41 multiplied by x equal to. The right hand side, since this cancels, what remains is just 41 negative 4100. To solve for x, we must have to eliminate this negative 41 here. So we will divide the left and right by negative 41. Negative 41x over negative 41 equal to negative 4100 over negative 41. Actually, there should be a quantity here. Okay. Because we'll try to make some cancellations. So this negative 41 here, cancel with this. Right? This is now 1, this is now 1. So what remains on the left will be x equal to. For the right hand side, this is a negative over negative, so supposed to be the answer is positive. Okay? And this 41 here, cancel with this. So there is a 100 that remains. So x now will be equal to 100, our answer. Okay? Okay, that's it, guys. If you could make these steps, okay, sequentially correct, of course your answer will be correct because as you proceed, you will be using the concepts from the past lessons. Okay, good evening from Los Angeles. This is Professor David Deletre.